Welcome to Rges, Algebra 2. This is lesson 1.5, Equations. Now, we've already discussed the idea if we had x or 7x plus 2, and I want you to evaluate that or assign a value to that expression if x equals 3. What do I do there? Every time I see the x, I have to substitute a 3, obeying order of operations. I get 21 plus 2, or 23. That is called evaluating an expression. Now, that is different from what we're moving into now. What we're moving into now is the idea, let's say I had 3x minus 5 equals 16. And I'm telling you what the entire expression, this is the expression on the left, I'm telling you what the expression equals. In evaluating, you are figuring out what the expression equals. Now I'm telling you what the expression equals. It equals 16. But I want you to figure out what the x would have to be in order for it to equal 16. We call this solving for an equation. It is an equation because it has an equal sign. Now, you have done this before. Remember that what we try to do is undo each operation one at a time. On the left-hand side, what two operations do we have? We have a multiplication, because a constant times a constant written next to a variable means multiply. 3x means 3 times x, and I have a subtraction. What undoes multiplication? If I'm going to multiply by 3, what would undo that? Divide by 3 or multiply by the reciprocal. If I'm going to subtract a number, what would undo that? Adding the number. If I'm going to add a number, what would undo that? Subtracting the number. And if I'm going to divide by a number, what would undo that? Multiplying by the number, right? Okay, so these are my basic, this is the basic chart on how I undo an operation, right? So this is all review from Algebra 1. My question now is I have two operations, the multiply and the divide, and the subtraction over here. Which one do I have to undo first? Well, we do it in the opposite order of the order of operations. So in the order of operations, I would first have to multiply, and then I would have to subtract. So when I'm undoing, subtract first, and then multiply. Or undo the subtraction first, and then undo the multiplication. Now that should be a review from Algebra 1. So let's see if we can do this problem. I want to undo my subtraction first, the opposite of the order of operations. What undoes? Subtraction, adding. So I need to add a 5 to both sides. At this stage of the game, you do not need to write that down, because I think that you're familiar with this. So do it in your head. I'm going to add 5 to the left side of the equation, leaving me with 3x. Because adding 5 undoes the subtracting 5. Don't even have to cross that out. Just on the next line, write this. Notice I'm not putting an equal sign there. Why? Because I'm not evaluating an expression. My equal sign now is in the middle of the problem. Okay. So 3x, there's my equal sign. And what did I do to the left side? I added 5. What must I do to the right side? Add 5, and that becomes 21. Now I need to undo my multiplication. How do I undo multiplication? By division. So I'm going to divide both sides by 3, giving me x equals 7. As my last step before I circle it, go ahead and plug it in mentally. 3 times 7 is 21. 21 minus 5 is 16. So you did the answer correctly, or you did the problem correctly. Now they're suggesting that at your final step that you would write the variable and you would write it in set form. When you have a single answer, it is absolutely fine for me to leave the answer that way. Later, when we have more than one answer, you will have to write it in set form. So he's getting you used to that, in the habit of doing that, which is fine, but I consider this optional when you have a single answer. Non-optional when you have more than one. Working through some example problems on the next page. This would be page 22 in your text. It says solve x plus 3 equals x. Now think about that a second. What number, if I added 3 to it, it would equal the number I started with? Is there any? If I had 4, 4 plus 3 would not equal 4. If I had 0, 0 plus 3 would not equal 0. Right? If I had a negative 2, negative 2 plus 3 is 1. That does not equal negative 2. There's no number I could plug in there that would give me that answer. So my answer here would be no solution. I could write it out like that. That's acceptable to me. Or I could say S equals the null set, no solution. Or I could say X equals, and in braces, where normally I would write a value, I would write nothing, and I would close the braces. All three of these answers are synonymous. For example 3, it says 3x minus 4 times x plus 5 equals 0. Well, first off, let's observe this for a minute. 2 parentheses written right next to each other like this means multiply. So you're asking yourself fundamentally, what number or what value times another value would equal 0? And I would only get a 0 for my answer if either this value equals 0 or this value, that's supposed to be an or, sorry, or this value equals 0. So I have to have 2 answers for this equation. First, I would set 3x minus 4 equal to 0, or, notice I don't need both of them to equal 0, just one or the other, because anything times 0 would equal 0. So solve each one separately. Adding 4 to both sides, I would get 3x equals 4. Undoing the multiplication, so multiplying by 1/3 or dividing by 3, I would get x equals 4/3. Or subtracting 5 from both sides, x equals negative 5. Let's see how that works. Plugging back in, 3 times 4/3 is going to give me 4. 4 minus 4 is 0. 0 times anything equals 0. Or, plug in on this side, negative 5 plus 5 is 0. Anything times 0 equals 0. So how would I write my answer this way? X, now I would need to do my set notation. X equals 2 values. I typically always write the negative value first. Negative 5, I write them in chronological order, and 4/3. 2 answers, 2 possible answers to that equation. Now we can also introduce the concept of domains. The domains would be your solution must be within the context of a certain group of numbers. If I said the domain for this answer If I said the domain X has to be an element of the positive integers, which solutions would work? And the answer is neither one. And so under that condition, the solution would be the null set. If I said the domain is X is an element of the integers, which solutions work? Only the first one. So X equals -5. So we do have to tie our solution to our domain. Typically, in your Algebra 1 you worked in last year, if you were with me, we always assumed the domain was the set of real numbers. But now he's going to ask you to be more analytical and confine your answers to the domain that he gives you. This is a domain, and this is a domain where it confines the elements or the set of numbers that make the answers legitimate or not. Now we're going to have to go to a part 2 in section 1.5 to finish our ideas.